everybody, and pass across to Andrew Moore. Thank you.
Awesome. Thanks, Margaret. Hi, all. So again, hi, nice to meet you. My name's Andrew, or Andy. I'm a digital forensics consultant. I'm also a lecture practitioner who works at Ruskin University. I'm the course leader of the BSc, Digitech, which is the Digital Technology Solutions degree. We study in cyber, network, and software. I also, we're starting to run a cybersecurity course with a forensic spin in cybersecurity coming up very shortly at ARU, so check it out. So today, I'm going to go through some of the bits and bobs of how to actually get into cybercrime forensics or digital forensics itself. The way I want to go about doing this is to be very practical. So there's going to be about maybe 2 slides of kind of waffly you kind of need to know, followed by we're going to go through all the bits and bobs of how you actually do it and actually how to do it for free, which is probably the best scenario, because no one should ever be spending thousands of pounds in software that they may or may not ever need or use. All right, so, oh, and finally, we're also, ARU, we're also a Bronze Award member for the Athena Swan for the Gender Charter. So just wanted to point that out. All right, so so it goes well. Again, nice little corporate slide, always very nice. All right, so again, a quick little bit about myself. So again, course leader at ARU and Digitech. I consult for a Cambridge startup also called BotProbe that deal with malware in virtual environments. I've worked on a range of UK and EU projects in digital forensics or digital forensics certifications, digital forensics education, through Cyber ASP or ECTEG, the European group for education. I also hold a number of certifications, such as the Certified Forensic Investigation Practitioner, CFIP. I got CSIR, which is the Cyber Incident Responder. I've also got the Certified Malware Investigator as well, from PA Consulting, or Safe, as you might know them as. And I hold a bachelor's degree in Information Security and Forensic Computing. Ironically, also from Anglia Ruskin over 10 years ago. So yeah, kind of full loop. In my own time, I play guitar. I would show, but it's on the other side of the room. I also play some football, and I play a lot of computer games because games are fun. Always a good way to de-stress or cause more stress, depending on when you play. All right, so how we do. So first, digital forensics and its various flavors is what we're going to cover today. You may hear many different types of terms. I'm going to try to keep the terminology as straightforward as possible. The idea is to give advice on getting started in these roles. That's the kind of primary role of this. And we'll also go over the common soft and hard skills. So it isn't just because I know so much or I do so much, that's only one part of the pie. So it is, especially whenever you're working in a team. I'm going to give a quick little demo that I've recorded. It's about 2 minutes long, I think, and I'll stop and start it. And what we'll do is we'll have a look at some prefetch files using some open source software. So what they are, how they work, why you care, and of course, you know, what they mean in respect to investigation. Also, it's quite fun to see what you know, because your computer will likely know more about what you did than what you did yourself. Finally, I'll go through the range of career paths that you can actually take to get this. So we've got free tools and build up a home lab, because home labs are great during the pandemic. A lot of people went and bought these. That's kind of why computers are kind of hard to find at the minute. But you can do them yourself. You do them in the cloud. I kind of show how that works. I'm also going to go over evidence samples. So at the end of the day, you don't need to create your own or make up some random scenario. There's plenty provided for you from large organizations to small ones, and they're all free. And then finally, some learning resources. So where you get the software from, where you get these operating systems from, and that kind of thing. All right. So providing it works. Hey, look at that. So first things first, what is digital forensics? What I need to do is just squeeze the presentation slides down. There we go, just so it doesn't cover half my screen. So digital forensics is the practice of identifying, extracting, and considering evidence from a digital media, such as a computer hard drive. So in other words, you are wanting to do investigation, say magically the police ask you to do some work, you happen to be an external consultant for them, you come into a briefing room, you sit down, you say, oh, this person's dealing in some kind of illegal material, they might be selling it out of the back of their house, so they get raided. So the police go do their thing, they handcuff them, set them down there and couch and whatnot. After that, you go in and you have a look through their shader, wherever they happen to be doing it from, and you will copy their hard drives and take it back to analyze it, or maybe do some analysis on the scene. It depends on the scenario, but we'll go through those. So digital evidence, and as I said about analyzing, can be fragile and volatile. So for example, if you have a phone and it's turned on, those files in that phone are always changing, even if you're not using it, because your phone's always, getting data from your 4G, your 5G. It's got Wi-Fi access potentially. Other people can access the phone. Apps talk in the background. People may notice their battery life dying very quickly. It's all very true. So these things change data, and they change data all the time. So every second that phone sits there, it's different to the second previous, compared to a hard drive, which is completely turned off, not doing anything, moving. It's always best to have a look at that, or leave that alone for last, because at the end of the day, you can sit there for a week or 2 weeks and you'll still get the same result. So we need to work out how we can actually get some evidential value from this. To do this, we have to figure out how do you effectively isolate the stuff. So is it worth turning the phone off? Is it worth keeping the phone on? Can you put it into airplane mode so no one else can connect to it? Can you actually get into it at all? Does it have a PIN code? Extracting it in a scientific manner. So that's getting the data out of the device, whatever it might be. It could be an Amazon Alexa, it could be the Fitbit on your wrist, or it could be, your laptop at home. And of course, will it stand up to scrutiny in a court of law? Because the process you take and the documentation you do with it is literally as, if not more important than the evidence itself. Because if you don't do it in a very specific way, unfortunately, it may not be considered to be legally obtained in court and therefore not admissible as evidence. So the first waffly slide. So some reports were done recently from the Police Foundation, and they state the importance of digital forensics as a core capability within policing and the criminal justice system cannot be overstated, which is true, because many potential crimes have some form of digital evidence to be analyzed, be it CCTV cameras, phones, Fitbits, even cars now. I mean, everyone must know about the car revolution going on. Effectively, it's a computer on wheels. Well, they always have been really for a long time, but now even more so. It's also not easy to assess the public value delivered by digital forensics for a number of reasons, because at the end of the day, you're a bunch of nerds in an office doing work that you never sit in front of a podium and chat to anybody, but also it's not ever really acknowledged. It's part of an investigation. The investigation team as a whole always talked about, or the lead investigator of that is talked about, but not that little bit of that team. So there's no consolidated picture of the value it generates. And an area of consideration is in a considerable change of flux. So there's little academic research on the impact of digital forensic work in the police. You can read many documents and theoretical stuff. You can read white papers with the kind of come from companies say, we did this work, we found this artifact that no one's ever talked about before or could never use before, and we found a way to do it. And that's quite a good read, but not on the actual impact of, so that information is now in the public domain, so how does it help someone? And then of course, later the report states the benefits to the public itself. So even though they're not perceived benefits, what actually happens: swifter justice to identify earlier offenders and speedy exoneration of innocent suspects, purely because digital evidence is all around. It doesn't really change its opinion because it's, it's a piece of evidence. Depending on how we analyze the evidence, we get a result. So if we can prove someone wasn't in a location at a time because their phone was on them, or they were live streaming on Twitch, for example, and you can see clearly that they're in their own house, it kind of proves they weren't somewhere else. The prevention of potentially large numbers of future crimes by supporting the identification and conviction in a court of prolific offenders. So in other words, if someone's a continued offender over and over again, it's not very good. So making sure that there's enough evidence to make sure that person can't hurt anyone else is obviously very vital. And of course, it reduces the time in an investigation. So for example, you may never actually go to court with evidence. So you can say, oh, I have this evidence shows that you did this crime. The evidence might be that damning that they won't go to court, they'll just plead guilty to get a lower sentence. Because by the time you go through the court process, your sentence will be typically worse if you obviously are convicted in a legal manner. So, food for thought. So the actual professions. So digital forensics, what is it? What do we do? So there are many different types of forensics that you can do. And this is not an exhaustive list by any stretch. These are kind of the ones that students typically go into as jobs. So therefore, it's probably the best ones to have a look at for you guys. So first up, we have data recovery. So simply recovering data from devices. It can be damaged devices or fully working devices, but damage here is the example. So it could be a burnt out CCTV camera. It could be a hard drive, or it could be a memory card from a phone. Regardless if it's not crime based or incident based, it could still simply be data analysis or data analysis. Sorry. We also have something called e-discovery, which works on something called the EDRM, or the Electronic Discovery Reference Model. A mouthful, I know, but effectively it is getting, say, billions of files and even petabytes of data from large organizations in unstructured ways. So, everyone's mailbox, everyone's a copy of their PC, everyone's a copy of their phone, the phone records, your network data that comes from a company, all of that together. And then you think, right, so how do we possibly analyze such a large piece of data? Well, what this does over 7 stages, it actually lets us pull parts of that data out. And eventually we go from billions of files, literally, down to about 10 documents after a legal review. So you've got a legally partially privileged review where you would have a bunch of reviewers look at documents that we find. They then, it could be lawyers, judges, police, take your pick, or fire brigade even. And they will look at the document and go, this looks relevant to this particular narrative they've been given or not. And after we do this a couple of times, we go from, again, millions, hundreds, tens of documents down to a few, and then that few is packaged up as a delivery and sent to court as the evidence found. It's quite good. Time consuming, but it's structured in the scientific way it works. We also have mobile forensics. I mean, everyone has a phone or two nowadays, unless people are actually using actual traditional desktops and laptops nowadays, because phones are actually getting to be quite good. So mobile forensics is a bit of a minefield, because Windows, for example, Windows 10 has been here for a long time. Windows 7 has been here for a long time, and they all run off the same file system, NTFS, or the new technology file system below it. So it's well known, well established. Phones, on the other hand, you can have a Samsung phone, an S10, for example, for me, but you could have 10 or hundreds of thousands of different versions of Android. It's an open source software, and it doesn't mean that your software that works for Samsung works for Motorola or BlackBerry or so on and so forth. And Apple are their own problem. Very specific software to deal with Apple, different file system, different set of standards, and there can be quite hard to get into. You have network and cloud forensics, where we look at data in the cloud. So you look your Amazon, AWS stuff you may be of interest in, or maybe it's Google Cloud, or maybe it's Azure, which is Microsoft's cloud and solution. We also have malware forensics, where it's getting into the nitty gritty of what malware did. You may hear at one point or another that the malware did it, I didn't do it. And believe it or not, in a court of law in the UK, you're innocent until proven guilty. So someone has to do the analysis to prove that malware didn't run, or if it did run, it didn't do that specific thing. So yeah, it can be a lot of fun. And then, of course, IoT forensics, Internet of Things. There's no real standard for Internet of Things, really. It's a bunch of devices that effectively talk to each other. That's the Internet of Things in a nutshell. These devices can include, again, Samsung SmartThings, the Amazon Alexa you might be listening to right now, or something along those lines. Again, your Fitbit under arrest, for example, could be another indication of that. So typically, starting jobs for these areas. Now, most people in forensics start as an analyst or a technician. It's kind of the lowest area as such. That's good, because low areas mean lower expectation from an employer, because that means you need to train you and get you ready. And that's good because, your degree gets you to a point. You then learn on the job, you get your certifications to go with that through your employer, and then you become competent. Competency typically comes from two things: your training and your experiences. So you might be trained in your degree in a sense of, I've, went through these modules and I've learned this stuff, but it doesn't mean you have any on the job experience. So you understand it, but you never did it. So how can you say you're competent in it? And vice versa. You could be doing it for many years, but have no qualification or benchmark or certification proving in piece of paper that you can do this thing. And I know that sounds a bit odd, but when it comes to legal cases, a barrister can argue that this person's not qualified to do this. So, that could be a huge problem, especially whenever a jury or a judge has to take that into consideration, depending who the fact finder in the case is. In the police, you'll typically start in the high-tech crime unit. There's new names for these depending on which force you are and how it's evolved, but let's go for it for a general term. And there are different ones, for example. So Bedfordshire is one of our closest ones, for example, in Cambridge. And you've got the ICAT team, CCIT or DFID team. Some are online bullying, some are like online kind of thing, social media. Some are specifically a digital forensics unit. You actually go out with the police and do recoveries, or they bring stuff back and you analyze it, so on and so forth. And there's a link there to the Bedfordshire Police presentation of what the jobs are, how they work, etc. So a good little supplementary read if you are interested. Other non-civilian based ways include becoming a police officer first, and then moving internally to a computing role, or of course going by the military. Some places are really liking police degree apprenticeships. Currently at Anglia, we have one, for example, and in the Eastern region, it's soon maybe going to become a thing where you might have to do an on-the-job placement or an on-the-job apprenticeship like this to actually get a job as such in that particular area. And then finally is consulting. So consulting is the way that I went. Now, consulting is a bit different because you may need to be a little further in your development for this type of job. But I'll go through how, what problems I've came across over the years and how I've did my best to solve them. And I think that instead of someone having hit their head against a brick wall, maybe they can learn from the imprint that my head's made on the brick wall and maybe not do it. All right, so let's get some advice. So firstly, on an educational point of view, remember that we talked about the competency, how it's built up. So first up, we have our technical honors degree. So I did one in digital forensics and information security. Pretty straightforward, that would be your job, right? Because it's in your title. Other ones you can, of course, go for as a generic computer science degree, because at some point you will have covered operating systems, how to, get around an operating system, not in a digital forensics way, but simply you understand the premise of how an operating system works. You may have also came across cybersecurity degrees, which would have came through anything from cybersecurity in general, penetration testing, any of that kind of stuff, any data science, any analytical thing also is really helpful, because digital forensics is effectively data science, where we try to find trends in data. So, did this person do this thing at this time? So you look for that one piece of data that shows that, and then you can analyze that bit of data to prove or correlate or see a causation. And, this user one day stopped doing this, and we don't know why. And that was the day that the alleged incident took place. So therefore, that could be the causation or the beginning or showing of that. You can also, of course, have a job in networking, because network forensics is an area that we went over, or cloud forensics. So it's definitely something you could potentially look at. But it doesn't just have to be computing-based degrees. I've also came across people in the days with either stuff like investigative study degrees, criminology degrees, because they go through the investigative mindset, which is something that I found difficult to get my head around whenever I was a lot younger. So, and I never really saw the value in it until it was said to me multiple times, oh, you really should think about doing this instead. So it's not your technical ability, it's simply, the thought process of how you got there. So, because that's drummed into them in these kind of degrees, then you may require a small computing top-up depending on the structure and the degree pathway taken. So simply just to, make sure you have that technical knowledge to give you a more rounded area or a rounded platform to sit on. Additionally, GCSEs, computing and math is quite straightforward and, something you definitely should have or do. And again, your A-levels, computing in your A-levels is very important, of course. And of course, math at A-level 2. I wouldn't say it's specifically required, because you can do data science with not being a math major. it would just be a bit harder. That's all. So yeah, food for thought. There are other degrees, like my boss had a geography degree as an example, and he's way smarter than I am. So, just as an example, there are other degrees, but these are the kind of typical ones you may see. So again, fundamentals are key to your success. So starting in one place and building up your knowledge is very key before moving on. I tried the topic of, I can do a lot of things, jack of all trades, but master of none. You kind of end up, hopefully, in the end, as a jack of all trades, but master of some. And because remember, a team is quite big. You're not going to be the best thing at everything. As long as you understand that, you have a better understanding of how it should work. So starting in Windows forensics is a very key idea. Why Windows? Windows is the most popular operating system on the planet, excusing phones, of course, because Android would be that technically. But the corporate environments that you will actually be getting for clients will likely be Microsoft-based. Yes, you can come across Mac-based environments and design studios or sound engineering, because that operating system particularly goes well with those jobs, historically anyway. Or Linux. Linux is very important, and you should definitely go through it. We'll go through this a little bit later on. But typically, Windows is what you're going to have to understand to be able to use. After you've dealt with Windows in general, then you can move on to other operating systems, because you can take some of the skills and knowledge you got from Windows and apply them. They won't directly apply, depending on what it is, but it's at least a very good understanding of what you'll have. Also, depending on the work and employer you're with, you may need to pass some form of security check. Now, security checks in the UK can be a Scotland Yard baseline. So that's like if you are a trustworthy person, simply, is your CV correct? Had you have any, problems with, the law and whatnot? Any convictions, that kind of thing that would literally prevent you from being in this job. We then have something called SC, which is security cleared, which tracks again, if you're a honest person, but also if you have any financial difficulties. So can you be easily bribed? And that would obviously be a huge problem if you could be easily bribed. Of course, then you get C2C, which is counterterrorism clearance, and then DV, which is developed vetting. Police officers may be subject to developed vetting, and others. It depends on your level and what you do. Much more in depth as it kind of goes up the scale. But typically, a baseline in SC is what would be expected consulting-wise if you're doing X-List consulting work, for example, on an X-List site, where you could see secretive information in the government scheme. But if you're looking at top secret information, then DV is required. So, advice. So how do I actually go about doing this? So I'd recommend, regardless of the employer, I would hope they would agree that a home lab is a very good starting point to start or continue your development, be it locally virtualized or cloud-based. And we'll go over virtualization a little later on. But effectively, if you haven't got the experience on doing something day to day, how can you get a job? And a lot of jobs have this catch-22 where I need experience in it, but I can't get the job without the experience. So you see, so how do I get the job, right? And this is probably why, if honest, the UK has one of the largest skill gaps in the UK is cybersecurity. 50% of cybersecurity is down to incident response and digital forensics, according to the UK government's report, which is from the Office of National Statistics. Very, very interesting. So it's a very good and lucrative area to be getting into, because there's a lot of places looking for jobs. And in the last 2 years, there is only roughly 19% of those jobs have actually been taken up. That includes through the pandemic and everything. So, take it for what you will as statistics go, but it looks to be a very important place to be. So regardless of who you are, it could be a good job. The other thing that I'd have a look at is a portfolio. Now, in my apprenticeship, we asked our apprentices to do a portfolio. I mean, let's be honest, everyone hates doing paperwork. You got to do a portfolio of what you've done over 4 years, is what it is. But at the end of the day, you have a good understanding of hitting all these key indicators, or we call them knowledge, skills, and behaviors, KSBs, that, make up the overall understanding and validate you're at that level when you finish your degree. Now, this is nice and all when you say it, but one of the other key things we need to look at is if you can do something or not. So if you did a portfolio, you built your own little home lab, and you decided to go through some of these examples, which we'll bring up very shortly, and maybe the demo I'm going to show as well. And in that demo, some very interesting things you'll see. And you can do it at home, and you can document you doing that and your understanding of that process. So when you go to an employer, you can go, don't take my word for it. Here's my portfolio. I've done these things. And originally, again, I thought they were for art majors only, oh, I'm not painting a picture, am I? Well, actually you are. You're painting a picture of you and what you are. And showing what you know and what you don't know works in two main ways. It's reducing the risk because the employer knows what you're good at and knows what you're not good at. And there's evidence to show what you're good at, which is very key. So it reduces risk and it's a higher chance of you getting employed because, end of the day, every business has to manage risk in some form. The other reason, I suppose, is at the end of the day, you need to also have a good understanding of where you are in your development. And if you're trying to apply for the managing role of a digital forensics team, but you can't do digital forensics very well, and you have no evidence of that or a previous job to back you up in that scenario, it might be unrealistic. So, always good to have. And if anything, it bit me quite hard in the past when I was shown stuff and didn't actually sit down and write down everything that I learned. And so take it as a kind of a life lessons from me, if you will. If you're showing something, write it down, put it away in a folder. Then if you're asked to do it ever again, go back to your folder. Right, no worries, I know how to do that. So common skills. Now we're going to look at hard skills and soft skills. So first up, let's look at the soft skills. So everyone should more or less have these in kind of any job you come across, really. But firstly, can you work in a team? And it might seem kind of odd, but in the front of my slides, I said that I play football, I play guitar, and you kind of think yourself in a CV. Why would an employer care about those things? Well, a football game is a team-based sport. So can you play in a team? Well, if you play football often, you probably can't play in a team. Can you work by yourself? Well, guitar in itself, it's, as you may know, if anyone's played any kind of instrument, it sounds awful until it sounds good, and it only sounds good by practicing. So if you're dedicated and can go through things, or you've did like a certification in like a classical guitar. I did one to grade 8 when I was at school. I hated history and it was my other option. So yeah, but effectively, that was one of the ways that I can show to an employer, oh, I've done these things in my spare time. Another key thing I actually like to show is gaming. Now, not just like, oh, I play games, but it's to show that through guitar playing, football, or games, I can show that I can de-stress and come to work tomorrow happy. It's always worth knowing, worth saying, because, jobs can get stressful regardless of what you're in. And as I said earlier, by taking notes. So again, building a user guide for tasks, making sure it's part of your portfolio. So, if work comes in, you've been shown it already, you don't have to ask someone again. And then when you get more senior in your job, you can have this as a user guide for the new people coming into the business. So it's in the business interest to let you write this, but it's also in your interest because you're going to benefit and they're going to benefit. So everyone wins. As far as this particular job goes, travel is quite important. You have to be willing to travel. And it can also be outside of the UK. So like collections where you're collecting digital evidence, you go to a PC, you copy it, you bring it back, or you go to a server room, cover a bunch of servers, bring it back. Manage your own time is also very key. Again, this is something that I personally have just learned over time. I would say, oh yeah, these are my tasks. And, I kind of sat and did them and it was what it was. But nowadays, you need to have a bit of a structure, of a plan. I never really took into consideration back then how much time it takes to plan a task before doing it. So yeah, life lesson. In forensics, you're going to have to spend only so much time on site because you only have access to site for so long. For example, a business might be running still at this very particular point. Don't want to lose money. Not going to stop just because you turned up. So you have to deal with 1 or 2 employees' laptops at a time. They go on to lunch or they have a half day or something like that. So the business don't particularly lose out. But when they come back, they're expecting a laptop working perfectly and to be given it so they can go back to work. So managing time is very important. And interact with clients or law enforcement directly. So some people, love to chat or whatever. When I was a lot younger, I couldn't talk at all. Now I don't shut up. So it's always good if you can sit and have conversations with people, even about casual things, just so that you have a good opportunity to talk to your clients and try to, make them open up to you a bit more. And again, same for paralegals or any kind of law enforcement as such. You're going to want to make sure that you can talk to them in a very structured and specific way to get the information you need, so they can walk away and say, Andrew's going to do these things, and you can walk away and go, I have to do these things. So hopefully they're not different. As far as hard skills goes, a good grasp of legislation is very important. You shouldn't be acting in computing without any form of legislation knowledge. So again, the Computer Misuse Act, or CMA, for example, I've written there. It's an offense to do anything to a computer that you don't have permission to deal with. So because you're unauthorized access to a computer, so you must have it signed off in writing saying you have access to these people. We're in a lawfully specific case in the scenario. So, I have to have permission to do these things. RIPA, it's very important as well. If the Regulation of Investigatory Powers Act is very important to understand. It tells the difference mainly between taking data in a coverted surveillance way. So you're not allowed to stalk people in the UK. I mean, as you might imagine, but you can legally do it through RIPA, through the police. So they can get a warrant suggesting that they're allowed to survey you in very specific conditions. Another one is the interception of data. So if they are going to be intercepting data from you, like text messages, or if they're going to be making copies of your devices or stuff like that, they need a warrant that specifically shows that. GDPR, also very important, the General Data Protection Regulation. So obviously it still governs us, even though we left Europe, we still have to apply to it. But if data is available, who holds on to it, how long you can keep it for, and that you lose all rights to your data when you kick the bucket. So yeah, very interesting that. And finally, PACE, the Police and Criminal Evidence Act. It basically gives you your rights to stop and search. So if someone is stopped and searched in front of you, they weren't read certain rights, they hasn't done the specific way, they aren't given their legal, requirements to, do certain bits of it, or if it's not done in a structured way, then of course it could be an illegal search, in which case any evidence you find on them is, invalid. So yeah, keep it out. We also have other regulations, or ISO standards. They're international standards that we have to abide by. 27101 is the general one for information security across pretty much every organization you'll come across. It's very important to understand that. 17025 in forensics is very important. There are many others, but that's a big one. Typically, if you work with the police or want to get evidence from another forensic lab, you have to have certain standards in place to show that whatever you're doing is good, and that when you can take that data, it won't magically become invalid or contaminated or corrupted or go missing. And then when you send it back, that doesn't happen either. And the ACPO. Now, the chief police officers, they have many new names, but it's always been known, at least to me and other colleagues, that it's still called the ACPO guidelines. 4 guidelines. Typically, the first one is we're not allowed to change original data. So if data is original, we have no reason to change it. So, we need to make sure that we don't change original data. We use write blockers to stop writing our particular data to any client machines or any potential victim machines, because you don't want to contaminate it. And if it's contaminated, then it's no good. Principle 2, however, is also quite interesting. So if you are to change original data, you have to say to the scope that you're changing it and why you're doing it. This is quite important for phones, because with full disk encryption, typically on phones, and a standard on pretty much any flagship Android phone, and it's compulsory, I believe, on Apple phones. You can't just turn the phone off and then pull a hard drive out. It doesn't work. It's soldered to a port. So unless you wish to literally take the phone apart and do, if you have an electronics degree and a lot of experience and can guarantee put it back together, you have to turn the phone on. You're going to get the PIN code, and from there do a live acquisition. Phone turns on, data is always changing. So every time that someone does this, they're going to see what you did previously, and then that person will see what you both did previously, and so on and so forth. So it's very important to understand that. We also have ECPO 3, very important, about paperwork. Simply document what you've done. So if anyone wanted to question your work or how you got to something, good. That's good. They can do exactly what you did and get to the same result. And then fourth is my favorite. It's someone else's fault. Typically, the officer in charge is the person who is in charge of the investigation and has overall responsibility. So they shouldn't be putting you in a bad situation by telling you to do something you don't know what to do, because you shouldn't be anywhere near evidence that you don't understand or have competency, talked about earlier, the training experience to deal with this evidence. Other things we have to look at are command lines. So we have CMD, which is built into Windows. We have PowerShell, which is open source, but also built into Windows. And Terminal, which you'll find on like Mac or Linux. Long story short, don't be afraid of them. I know you see code and stuff like that. It's a bit weird. It's a bit matrixy. We'll see some of that later. But effectively, learning it is very important, and it can learn you other things like automation. You know, click a button on your desktop, 5 or 6 things run. Great. So it is really handy. Saves time. IP addresses are very important. Ports, protocols, TCP, OSI models. There are networking models or network pieces to networking, like how our devices physically communicate with each other in software. So you need to understand that in some form. Also, a good understanding of hardware. And we talked about, you know, taking computers apart and putting them back together. Well, if you don't understand what a hard drive looks like or how to disconnect one, it's going to be a problem. Also, searching a computer for hidden hard drives or memory sticks, because, you know, you've got USB ports potentially on your board. One little memory stick in there could be everything you need. And then finally, an understanding of artifacts you might, you know, happen to come across. Some digital forensics, some popular ones are prefetch files, shell bags, jump lists, and the SAM file. Again, we'll go through those in a little bit. All right, demo time.
Andrew, can I ask one question?
Sure, yeah.
Yeah, there is my question about there is a malware attack from the hardware to electricity of any kind of oil and natural gas some company. Okay, and the electricity will be attacked by some malware like a rootkit. So can we forensic that case in particular manner? Is that possible?
You can use forensics on malware. I'll talk about some software and some operating systems called Remnox, and which is the Linux-based one, which is the open source one by Sans, and the other one, which is Flare, and it's by FireEye, and it's a Windows-based one. I'll go over it and I'll give you some scenarios. Is that all right?
All right. Thank you.
Awesome.
Andrew, I think there's questions in the chat, but I don't think you've quite finished the presentation yet, have you?
No.
You carry on with the presentation first. Thank you.
Cool. Okay, so let's have a look at our demo. So first things first, what is an artifact? Artifacts are something that have been left behind. And so from a past event, so it's kind of like footprints in the sand, you know someone was there. In digital forensics, we call these historical artifacts because they happened before. And they're really handy because based on these findings, we can help us learn something new about ourselves, but it also can learn about someone's future or the person we're investigating. It's very, very cool. So in this demo, I'm going to show you what prefetch files are. So prefetch files are built into Windows. They're in a folder called C, your C drive, then Windows prefetch. Inside of the prefetch file, it's kind of like whenever you open Microsoft Word and you see it all popping up and it's loading and slow, then you open it, but you close it again and make sure it's completely gone. And then you open it again, it opens instantly. One of the reasons this happens is because the prefetch file is created. So what it does is takes a specific location on your hard drive of where those particular files are, and it tells Windows where they are. So instead of Windows having to search a hard drive for it, it will find it in a specific location, know where that is, and start right away. Now, that's what Windows uses it for. What we use it for is a few different things. So it lets us see evidence of program execution. So someone ran a program. They ran it from a particular location and when. It also tells us how many times they ran it up to a certain point. It's very, very useful. It even works if the program's uninstalled, because as long as the prefetch entry is installed there, everything's great because we have proof that a bit of software existed before. And again, this happens in Windows XP, Windows 7, Windows 8, Windows 10, so on and so forth. And there's a cheat sheet from Sans later on that you can have a look at as well. They give you more information on it. So I'm using a bit of software called Process Explorer by Eric Zimmerman. Very useful, open source software. It's all linked in the next slides. But effectively, what I'm going to do is I'm going to call the program to memory, or call to the screen in a command prompt. So what this effectively means is the program doesn't have a graphical user interface. It's not that type of program. So all I'm doing is dragging it in from the right to the left and running it. So again, learning what a command line looks like and how it functions is very useful. Now, in this command line, you have lots of functions. So you can't just say, click a button, do what I want. You have to tell the program what to do, because in forensics, we have to be very specific. So for example, I'm going to say this program, so the pcmd.exe, I want you to -d being, I want you to check this very specific directory. On the right-hand side, you can see I've highlighted C Windows Prefetch. So I want you to check the prefetch file or prefetch folder. And as you can see, there's a lot of .pf files in there. So I want you to scan those files. I then want you to output this data into a spreadsheet so I can, keep it for later. In order to do this, I need a format. The format that supports a CSV, which is a comma separated variable. So in other words, it separates data in commas. So what I'm doing is saying --CSV and telling it to go. At this point, it's pulling through those thousands of files or hundreds of thousands of files, automatically. So this is something that you would have spent many, many, many weeks doing. But no, you can do this one click of a button. So what's happened? In the end, it has created a couple of things. I'll just pause it here. It's created 2 files for you. So it's analyzed 146 files in 13.6 seconds. It's pretty good timing. What it's done is it's de-encoded these files to take them away from Windows's understanding and put them into more human understanding so we can read them. So someone else has done the hard work for you, in other words. At this point, you'll pop out 2 files. And they're both, again, they're like kind of spreadsheets, like Excel files, but open source. In these CSV files, you will see 2 outputs, one of them being, and again, they're set by time and date, which is quite useful. One is the everything that comes out, and the other one is the timeline of whenever people ran certain applications. So easy enough. So let's open one. Now, as you can see down below here, everything looks very smushed together, very hard to read, not very useful to anybody. But as it is CSV, it's comma separated. If we click on that, and all of a sudden, didn't mean to do that, it looks much easier to read. Hang on, what's that? Yeah, there we go. So it looks much easier. So, and we can open up the file. Now, the file's pretty useful. What it lets us see is a couple of cool things here. So on the left, we can see all the programs that have ran in order, very useful. Source created, so we've mace times, so modified access and created. So whenever the file was created, it's very, very useful because it tells us when that was installed on a computer or ran. The actual file of what was executed itself, so what ran itself. A hash value for this was very useful to prove that it's unique. How many times it ran is called the run count. The run count is how many times the program simply has run. You can see the last time that program is ran, and also the times it ran. You can see up to like the last 9 or 10 times. So you can, depending on the Windows version. It's very, very useful. So we can see PCMD on line 55, for example, is the one I just ran. So you can see it's ran 5 times. So, or 6 times, sorry, because I ran it there. So yeah, it's very, very useful. And you can prove if someone did something at a particular time or not. So yeah, hope you find that kind of useful. I know spreadsheets look boring and everything, but small kind of problem with the job, I suppose. All right. So home lab setup. So you can set up a home lab in many different ways for your custom learning environment. Very important because it's for you and not someone else. So you only learn what you need to learn. Don't learn all these other things that aren't going to be important to you. Saves time and effort. So you can either do it on your own PC or you can do it in the cloud through like AWS or Azure. For example, Azure and AWS have like credits for students. So if you happen to be a student at a university or college, you can actually get some credits for free to spend. So again, check them out. You can Google it. So you can maybe, if you haven't got like great computer at home to run this kind of software, that's fine. You can use the cloud stuff instead. You can also do it in the Raspberry Pi, and the latest model, the Pi 4, if you can get one for about 50 or 60 pounds UK, you can pretty much run all of this. It's quite good. So yeah, and again, it can be a fantastic tool to build your skills and show your potential to an employer. And again, trying to emphasize on that low risk of hiring you because you can prove you can do things. So a home lab here, If you home lab something, you want to separate it from your own actual operating system. So the kind of way this works is on the gray at the bottom, you've got your hardware. So this is your physical computer, the physical components. You've got your operating system, which is the host operating system, which is in blue. So it's just like Windows 10 that's running on your computer right now. You then use something called a hypervisor or a bit of virtualization software. All it does is it makes kind of like a fake version of Windows that sits inside your real version of Windows. So you can play with inside of it, do what you want. You can change files, modify, delete things, run malware, doesn't matter. At the end of it, you can simply delete it or close it down and nothing has happened to your underlying operating system. So it keeps your work life away from your private or personal life. It also doesn't let you contaminate any of the work that you've done. And it also makes sure your employer doesn't find anything embarrassing about you. Some good recommendations: have at least 4 cores and 8 threads. Hyper-threading or threads are important because some are going to go to your original operating system or some are going to go to your new operating system. Some RAM is very helpful, obviously, because you're running a lot of processes, and hard drive space to do this. And 2 screens. 2 screens are very important. I didn't have the money for screens back in the day being a student or a first worker. So I had a laptop and I had my TV and plugged it in and used that as my other screen. So, you know, I'm sure you must have one of those lying around. All right, tools. So that virtualization software I was talking about, VirtualBox is fantastic for this. They're all linked in the presentation. So when the presentation goes out, you can, grab the links from there, or you can just, copy paste, etc. So what this lets you do is a free bit of software made by Oracle, one of the largest database operators in the world. It allows you to create a sandbox, kind of what I was talking about earlier. So I kind of like think of kids in the sandbox. You make castles, smash them, make castles, smash them, whatever. Someone else can use it afterwards. It lets you can install any tools inside of it. And once you're done with those tools, you can, just delete them or make a new one. It doesn't matter. It's very, very useful. We also need to come across imaging software. Now, Kali itself, you may be familiar with if you're into kind of security stuff. It's an open source software that is used in penetration testing, Wi-Fi hacking, but also digital forensics. That's got a cool little dragon too. So the operating system is Linux-based. It is free. Just download it from the website. You can run it as a virtual machine, or you can install it on your hardware directly. Totally up to you, depending on your circumstances. You can even run it in memory, so you don't even have to install it. The OS contains software like Geimager, which is quite good. So Geimager is an imaging software that you copy a hard drive scientifically. And what it does, it takes a whole hard drive and it compresses the hard drive into a little zip file. And that zip file doesn't change. It keeps all the metadata and timestamps of the original machine. And then you can analyze that and pull files out of it, or copies of the files out of it. And everything in there is still exactly as it was whenever you copied it. Very, very good, because say, for example, in 2 weeks' time, someone plays with the computer, obviously things have changed. So getting a copy now will mean that, well, everything's different. So it might be very bad as far as investigation goes. You've also got a range of hex editors too, so you can change your hexadecimal, which is what your operating system uses. And the data you actually analyze will be in hex typically. Hex is 0 to 9 and A to F, so 16 characters total, just as if you didn't know. SANS also have one called SIFT. The SIFT workstation is pretty cool. Open source, it's very good. It updates itself. You don't have to go around 1,000 websites to get 1,000 different software. Doesn't matter. Download this, play with it, and you'll be very happy. Also, there's plenty of courses they do as well on it too. And it also links to the malware investigative software in the next slide called Remnux. So you can actually link data between the two of them. So you can do a forensic investigation and push the data into Remnux, which you can do a malware investigation or vice versa. Very useful. Remnux is the malware one. So as what the question I got earlier, it's Linux-based. It's for reverse engineering malware. It can do dynamic analysis and static analysis. Dynamic being the file isn't running. We're just going to pull it apart and see all the little pieces, see what strings, in software terms, what strings are available that you can actually pull out and put back in and see what it does. Or blacklisted strings, more of the point. So like, things you shouldn't be doing. Or its dependency. So what other files are inside and attached itself to this, or what it has attached itself to. Very important when looking at viruses or malware. And yeah, Remnux is free updates. It's got a bunch of software, and I do recommend checking it out. You also have Flare as well. I'm not sure if I came across. I didn't put Flare in. Flare is also one you can grab. as long as you have a version of Windows, you can install it from GitHub, FLARE. It's by FireEye, again, a large consulting firm that also does a lot of educational work as well. We talked about GaiaMagger previously, which was inside of Kali. We can use FTK Imager, which is Windows-based imager. So you can do some imaging through this as well. One of the tools I would use very often. It creates EO1 files. Remember that file I was talking about? It takes a whole hard drive and puts it into a little zip folder. That's an EO1 file or an open evidence file. And then it can be safely searched. It's very useful. So you can see all the files here in a NTFS partition, how big they are, and you can also see the file stamp or the timestamps and metadata of whenever files are modified. Again, very useful. The tool in the demo I use is by Eric Zimmerman, a guy from Crawl on Track. Very, very smart person. He has a lot of forensic software that's completely free. The site includes many tools, including the Prefetch parser that I use, which is very useful, or process executor. So yeah, definitely check it out. Some come with a GUI, so like it pops up and you can click buttons and stuff like that, but a lot of them are command line based, like I previously did. Again, once you learn to use one, you can use them all. GitHub is also pretty useful. You can search digital forensics and incident response, and currently I got 138 views a month ago. So again, definitely worth checking out. Awesome Forensics is very awesome as well, believe it or not. So it's a specific section in GitHub that I'm sure you must have came across if you're doing software or any computer science work. So yeah, again, they're all open source and free to use. So again, check it out. Now, there's no point having all this software if we haven't got any evidence to actually test. Like, you could create your own evidence, create a hard drive, pull it apart, all good. Or you can just download some. So NIST is a large organization in America. They do a lot of this work. It's very important that you understand that NIST or, for example, or SANS, so on and so forth. Also CREST as well, C-R-E-S-T is also quite a good one to learn about. So this portal is in your gateway to document the digital forensic image data sets. So it lets you go through a data set, let you pull out information. It's very useful. Data sets can be assets in different ways. So some can be mobile phone images, for example, here, Android based. Some of them are iOS based. Some of them might be databases. So you want to do database forensics. Some are hacking specifically. So they can be a little more in the terms of ethical hacking, as an example. And the rhino hunt's always good fun, just finding pictures of rhinos, you know. But yeah, but to try to apply it to something else, could you find pictures of someone that they've taken and hidden on their computer? So replace rhino with, you know, naughty image, and yeah, you've got exactly the same process. And there's also descriptions, and yeah, very useful. So definitely do check it out. We also have Digital Corpora, but are also very good. They do some kind of like entrance tests. Some places do these with. So it's kind of like a forensic image, and they tell someone in a job, they go, oh, I want you to see what you can do from this very narrow, you know, narrative. You got a couple of hours, have fun, and then you chat about them, you know, afterwards, what you did, how it worked. So yeah, definitely check that kind of stuff out. They're more educational based, but definitely, you know, worth doing, because I put them to some of my students for fun, and yeah, some of them have done really well. And finally, we've got some learning resources. So ENSA, the European Union Agency for Cybersecurity, is a great resource for learning digital forensics. They can give you an entire download and tells you how long it would take. So these are, for example, for technical staff. Now, again, it's very important to understand here that I know you're not maybe in this area particularly, or you may be looking at a career in a different area, and you may understand some of this, and you may not. That's fine. There's a guide there, the handbook. There's a tool set that you can go and get. There's a virtual image. So when we talk about virtualization, someone's made it for you. Just download it, play with it, and have fun. We've also got Windows tools and another sandbox called the Cuckoo Sandbox. There's plenty of sandboxes. You'll come across them. Some of the ones I've previously talked about are sandboxes. But yeah, there's loads of them. Check them out. They're all for really specific processes, but some are generic. We also have SANS. So again, I talked about them earlier. I love using their cheat sheets. They're very useful. They can give you some really good information that you can go away and test to see if that information is correct in your specific scenario. You know, because different versions of Windows might give you different results, so on and so forth. So it's always worth checking out. They're free, just sign up. All right. And I think that pretty much covers me. So in conclusion, what have we actually went through? So we've went through what digital forensics is and maybe why you should care in a sense of, as a good career choice. The roles went through, again, 6 of them. They're not an exhaustive list. Again, just what I thought might be useful because our graduates typically go into those areas. So I thought that might be the most useful thing. I went through the advice of starting. So building your own home lab, building up a portfolio of yourself and what you can do and what you can't do. It's very good because, again, I may not have mentioned it, but when you start a job, your employer also has an obligation, in a sense, to train you to make sure you're, ready to do your work. And if they have a portfolio of what you can and can't do, it makes it really easy to figure that out very quickly. And it's good for you because you can then, plug up the gaps that you have in your knowledge. We then went through the hard and soft skills of what you actually need to succeed. So again, being able to work in a team, being able to show you can work on your own, but also being able to travel. It's very important in this kind of job. But also hard skills. So, what kind of things you might be interested in doing or learning. Again, definitely stuff to understand and definitely stuff to check out. We then went through tools. So with sandboxes, forensic analyzing tools, where to get them all from. Everything was free. So there's no payments for any of the stuff. So yeah, check those out. We've also got evidence samples for you from NIST and from Digital Corpora. So you can definitely check those out as well. So you can actually have a go at some of them. They're also written guides. And if you look on YouTube, you actually find actual video walkthroughs for them as well, which is actually really useful. See, when you've done your work, you can check it effectively against someone else. And then finally, some resources. So you can, see what other things you can get up to. All right. I guess that's it for me. Thank you very much for listening.